Good morning, everyone. Thank you for making time to join us today for our inaugural GCG Automation Wake and Automate presentation presented by Empire, C&E Advanced Technology, ACDA, ACD, and AdCon. My name is Jim Hopkins. I'm the East Regional Sales Manager here at Empire. Today, I'm excited to present Sean Foley. He's the Snap Signal Business Development Manager in the US for Banner Engineering. Today, he'll be presenting IIoT Made Easy with Snap Signal. During this presentation, you guys should all be on mute. If you have any questions during the presentation, at the bottom right-hand corner, you'll see the chat button, and feel free to enter any questions, and we'll try to answer them throughout the presentation. Again, thank you again today for attending today's Wake and Automate presentation with GCG Automation. Without further ado, I'd like to introduce Sean Foley with Banner Engineering.
Hi, everyone. My name is Sean Foley. Thanks so much for the introduction, Jim. I'm really excited to be here to present to you all on Snap Signal. So Snap Signal is an IoT-enabling portfolio of hardware and software that allows you to get actionable data from across your factory. So in this presentation today, what I'm going to be covering is I'm going to be talking about some of the best practices when you're first deploying IoT, some myths we commonly run into when we're working with a lot of our customers when they're interested in deploying IoT technology or data gathering technology on some of their equipment. And I'm also going to be talking about Snap Signal as a whole. So without further ado, I'm going to get started and then dive into some of the products and the technologies. So the first thing I'm going to talk about is some statistics, and some statistics that really stood out to me and us at Banner when people are first deploying IoT technology is one thing that's really quite remarkable is that the average age of manufacturing assets across the United States is about 20 years old. So there's tons of manufacturing assets throughout the country, throughout the globe, that have been installed for decades. And we're going to be talking about that in a little bit as one of the myths we often run into when people are deploying IoT or condition monitoring technologies. They think, wow, IoT is this cutting edge technology, and it can only be applied to brand new equipment, to greenfield equipment. Another thing is that there's going to be immense growth in this area in the next 3 to 5 years. So the next 3 to 5 years, 46% of companies are planning to deploy IoT technologies. Companies are realizing that deploying IoT is a necessity to be competitive in today's market. Being able to reduce downtimes, being able to use data to optimize their systems. And that's huge. And also just the amount of spending on IoT technology is expected to absolutely skyrocket in the next several years. So when we're talking about myths, one of the myths I was talking about earlier is IoT, it's kind of a buzzword nowadays, right? They think it's this, many people believe it's this cutting edge technology, which it is. It absolutely is. But with that, some people often think that it can only be used on brand new equipment or greenfield applications. Think of like Tesla, think of Amazon. They've had very successful IoT deployments. But actually, what we're finding is the opposite. We're finding that most of IoT's value comes from retrofitting and from improving brownfield sites with this type of technology. And with this portfolio of products that I'm going to be talking about in a little bit, I'm going to be discussing some applications where we've done that, where we've added condition monitoring and IoT technology to machines that have been around for decades and improve the throughput of those machines without disturbing their existing control system. And that's what's going to be huge about Snap Signal. Another myth we often run into is the myth that deploying this technology always is going to require a huge amount of expense. It's going to lead to a lot of planning. It's going to take a lot of time. And also it's going to bring their systems down for periods of time. It's going to bring their equipment down for periods of time. And however, many are wary of these types of commitments. They don't want to bring their systems down. Oftentimes when I'm talking to people or controls engineers in a factory, they think when deploying this technology, they're going to have to dive into their control cabinet, dive into their code and their PLC. And I get the knowing look. It's, well, rule number 1 is don't touch the PLC, and rule number 2 should be follow rule number 1. They're very reluctant to do that, and that is totally understandable. And with Snap Signal, we're not going to be diving into the control cabinet. We're not going to be touching the code of their standard PLCs. And at Banner, we've really deployed a successful playbook when you're starting out with deploying IIoT technology. And it's really quite simple. It's to think big, start small, and move quickly. And so when I say think big, it means begin with the end in mind. Align with your corporate goals and strategies. What are you trying to do? Are you trying to reduce downtimes on things that are causing you a lot of money, are costing you huge amounts of money? And then start small. So find a high value entry point. And what I mean by that is I often like to ask people the question of what assets in your factory, if they were to fail, would be catastrophic to your production? And how do you currently monitor those assets? Do you go around with a clipboard and copy the gauge onto a clipboard every couple of weeks? Or do you have a system in place that continuously monitors those critical assets? And that'd be a great example of starting small, finding those critical assets. And then move quickly. Test your hypothesis, share the results, and build confidence and momentum in the data that you're gathering. And that's big as well. So start small. Where do I begin? Oftentimes, it could be something like on a motor. If a motor was to fail, it could really be catastrophic to your production in many applications. But it could be many different things. It could be the humidity in a plastic pellet hopper. I have an application example. We're going to be talking about that in a little bit. Vibration of a conveyor motor. If the motor goes down, your conveyor is not running anymore, and that's significant loss of revenue. Perhaps it's the pressure of hydraulic lines. These are all examples of where you could start small and get gathering that actionable data. And so at Banner, we've come up with a portfolio to really make this easy to gather this data. So where do we start? What SnapSignal is all about is being able to capture data from just about any source. And let's talk about that for a little bit. What SnapSignal is all about is being able to capture data from just about any sensor. So you may have an analog sensor, maybe doing tank level, for example, tracking your tank level over time. You may have a current transformer, something like this. You clasp these around the motor to see the current draw of your motor continuously. You may have a discrete sensor counting objects moving by. You may have a temperature and humidity sensor continuously monitoring the temperature and humidity of your environment. Or you may have a vibration sensor mounted directly on your motor, monitoring the vibration and temperature of your motor continuously on a conveyor line, for example. With SnapSignal, we're able to gather all this data, and what it's all about is really converting these sensor signals to a unified serial RS-485 protocol with these compact S15C converters that, as you can see there, are about the size of a AA battery. So really compact. We have about 30 different models of these converters depending on what signal type you're converting. And the power of that RS-485 protocol, that serial RS-485 protocol, is really powerful because you could tee into multiple devices and use T's to gather a lot of sensor data and bring it in what's called our DXM R90, which is this product right here. And so the DXM R90, I like to think of this product as the consolidator. You're gathering this actionable data from all these sensors across your factory, monitoring those critical assets, and sending it out to the world. This decode industrial Ethernet port, it talks all the important industrial Ethernet languages of Ethernet IP, Modbus TCP, and Profinet. What you could also do is you could also send this data directly to the cloud. So you could do HTTPS push methods to push it to what's called Banner's cloud data services. Banner has their own cloud data services. Or you could send it via MQTT to things like AWS IoT Core, for example. So this is a really greatly capable, flexible device for gathering a lot of data. And so that RS-485 protocol I was talking to you about, being able to gather a lot of data from across your factory is really powerful. And Modbus RTU, or RS-485, acts as the conduit for that data, that actionable data that you need. So let's talk a little bit more about the converters. So these converters, they function simply. They translate one signal type to another. And we have two different styles. We have converters that convert over to Modbus RTU, or that RS-45 protocol. We also have converters that convert over to IO-Link. So we're able to take these legacy sensor signals that are all over the world of industrial automation. Sensor signals such as analog, like your 4 to 20 or 0 to 10 volt signals. Your NPN or PNP signals that are maybe coming from a proximity sensor or a photo eye. And we're going to be able to convert those signals over to either Modbus RTU or IO-Link. And we have over 30 different models of these converters available. And as you can see, they're extremely compact. They use standard M12 connectivity. So you could plug this directly into your sensor or anywhere in line for ease of use. These are also IP67, IP68, so they're rugged, and they have LEDs for status indication. So what these allow you to do is it allows you to convert these legacy sensor signals over to these smart protocols. And then after they're converted, we're able to send it to the DXMR90 industrial controller, which is this product right here. So the DXMR90, again, I like to think of this product as the consolidator. You have the 4 individual Modbus master ports there at the bottom, or Modbus client ports. You have power on this M12 connector here, and you also have this decode industrial Ethernet port that sends the data out to the world via Ethernet IP, Profinet, Modbus TCP, or via MQTT to cloud platforms, for example. And so these have been deployed. It's been so far Banner's most successful DXM controller. If you're familiar with Banner's DXM products, it uses all the same programming as our other DXMs. So let's talk about some examples. Retrofitting legacy equipment. Retrofitting equipment that already has a control system in place and being able to gather actionable insight from that equipment. Well, here we just have a really simple example of that. Here we just have a photoelectric sensor counting boxes moving by on a conveyor line. With Snap Signal, you could use something as simple as a parallel wired splitter to plug in the sensor and have one branch of that parallel wired splitter going into the converter and one branch going into your existing control system. So it's running completely in parallel to the existing control system. The existing PLC is not seeing this overlay at all. And that's exactly what Snap Signal is. It's an overlay. So here we're able to therefore use that converter, plug it into the DXMR90 industrial controller. And in this case, we're just going to be sending it to what's called Banner's Cloud Data Services. So here we just set up a very simple dashboard from that just one discrete sensor, that one or a 0, counting those conveyors moving by, and we could get really actionable data on that conveyor line, like parts per minute, for example. You could do widgets for the overall performance of that conveyor. You could get part counts over time. And from this one single data point, you could get actionable data, and you can make decisions based on that data. For example, if you have many different conveyor lines throughout your factory, and you're wondering, well, why is one conveyor working a little bit better than another? Well, maybe on a certain day, you have a certain operator working on the conveyor, and you wonder, why is the productivity down? And you figure out, well, he goes out and bingo night on Thursdays, and on Fridays he's not feeling too well because he might have had some fun that night. You could use that data to make some things like personnel decisions, or you could use that data to optimize some of the technology on the machine as well. Being able to retrofit and use existing sensors with something as simple as a parallel wired splitter in this case makes it very easy for retrofits. So here we have some tank level sensors, and the same thing like that previous example. You could have a sensor that's already installed, like this one. One branch goes into your converter. The other branch goes to your control system. So this discrete sensor, it's being split, and you're able to convert that over to that serial protocol, plug it into the DXMR90 industrial controller, and then the other branch goes back to your existing PLC. So you have an existing sensor that you're able to gather that data from and send it to the cloud in this case. Here's another example for tank level. You may have some level sensors mounted above some tanks. And here what we're doing is we're capturing that sensor data, converting it over to a unified serial protocol, and then sending that data up to the cloud, all without disturbing an existing control system. Similar on another discrete application, we could use these discrete sensors that are counting bottles on a bottling line, capture that sensor data, have one branch of the splitter going back to the existing control system, one going into these converters that you see along here. And with that RS-45 protocol, you could tee in to many different sensors and have it go into the DXMR90 industrial controller. And the nice thing is, like I said before, Snap Signal is an overlay architecture. We're not diving into the control cabinet. We're not diving into the PLC. We're putting this over the top of an existing control system. So we're not touching the PLC code at all, and we're able to gather this actionable data insight. A nice thing too is maybe you have a lighting product that gives you status of a machine. You want to capture that data too. For example, you may have an output coming from your PLC turning on a light, a stack light, for example, indicating that there might be a fault. You could capture that data that's being sent to that light as well. So being able to capture outputs from a PLC is a powerful thing as well. Maybe you want to start adding more condition monitoring to your equipment. You could use some of Banner's QM30 VT2 sensors on your motors. What these sensors allow you to do is allows you to use magnets or other mounting accessories to mount these on your motors and continuously monitor the vibration and temperature of those critical assets over time. But maybe you wanted to have a couple of those. You wanted to mix and match. Maybe you wanted to also monitor tank level, for example, with one of our T30R sensors mounted above your tank. With Snap Signal, it's almost like Lego building blocks for your condition monitoring. You could really use just about any sensor type and convert that over to a unified serial protocol and gather our sensors that fit the application. The nice thing about these converters is that they're brand agnostic. So we could use these converters with not just Banner sensors, although we like Banner sensors to be used. We understand sometimes there's sensors that are better fit for an application. So we could capture data from other manufacturers' sensors with these converters as well. Being able to track raw material usage. Simply put, if your machine or your operation runs out of raw material, you're no longer producing revenue. So that's really a critical thing to asset. And in this application, we have some sensors monitoring some rolls. And what we could do is we could capture that data, convert it over to that serial protocol with these converters, and connect it to our DXMR90 industrial controller. And from there, we could send that data where it needs to go. And you could also send that data to your PLC, your SCADA system, or like I said before, directly to the cloud. A lot of applications too, people are using this overlay technology to send data to like an HMI. There's a ton of flexibility with where you could send this data. The nice thing too about this technology is that you could incorporate lighting products for a visual factory element. So what do I mean by that? Here in this case, we have some WLS15 lights that we overlaid onto this machine for visual factory element. So we're getting the data from this sensor, maybe sending that to the cloud where we could set up very simple alerts if the raw material falls above or below established thresholds. Or you could also give a visual factory element to personnel on the factory floor saying, this light's starting to go down, it starts to go red, it's time to start taking a look at ordering some new raw materials. So here's a quick little demo that highlights that. So we have an analog sensor, and this could be doing something like monitoring roll material. It could be doing something like monitoring the tank level, for example. And here we just have a 4 to 20 milliamp output. We're going to convert that over to a unified serial protocol with this converter, and we're going to connect it to our DXMR90 industrial controller. And from there, we could use that data. Maybe it's monitoring tank level, for example. We could send that data to your HMI, your PLC, or directly to the cloud. Many people have been deploying these types of solutions for sending data to the cloud where they could set up alerts if the tank level or the roll diameter goes above or below a certain threshold. And they could use that data to track that data over time and even set up things like automatic reordering, for example. But like I mentioned before, you could incorporate our Banner WLS15 lights, such as this, to offer a visual factory element to your application. So maybe you wanted to get that data insight, get that data availability from the sensor. But you also want to alert personnel locally that, hey, you know, the raw material's starting to fall a little low with a lighting product. So you also get that visual factory element to your application. There are also applications where end users and customers are using things like our infrared sensors, such as this. This is a sensor where you could point it at an object and it continuously monitors the temperature of the surface. So it's a non-contact infrared sensor. And you could have this mounted above some critical assets in your application, convert it over to that unified serial protocol, and connect this data, connect these sensor signals to the DXMR90 industrial controller, where you could send the data directly to the cloud. You could send it to your SCADA system. Maybe you're using Ignition. There's really a lot of flexibility where it could use this technology. Also incorporate some lighting products. Pressure monitoring is a big one in many applications. Like I said before, we were able to take that 4 to 20 milliamp or 0 to 10 volt signal from these devices, whether they're Banner devices or other manufacturers' devices, convert it over to a unified serial protocol, and capture that data before sending it to the DXMR90. So think things like maybe air compressors, air filters. Maybe you want to also mix and match and add some more sensors to this type of application. Hydraulic power unit monitoring. So being able to monitor the pressure, being able to capture data from something like a CT. We're going to talk about these in a little bit more detail in a little bit, but being able to clasp this around on a wire in your motor to continuously monitor the current draw. Because if the current draw of the motor was to suddenly spike, you could set up things like alerts to alert personnel, alert technicians on the factory floor that the current draw is suddenly spiked. You should go and check on that motor, have a Vibe Tech go and check on that motor to essentially serve as a check engine light for their automation equipment. Many applications too, we're seeing a lot of cases where they're gathering lots of vibration data and connecting it to a DXMR90. And what Banner has a lot of M12 connectivity products that allows you to connect many different devices to the DXMR90 industrial controller. But you could have up to 40 different QM30s monitoring many motors throughout your factory, going to this consolidator. And you could use one of Banner's existing solutions where we have a pre-built script that learns the baselines. You can install the QM30s. The script will learn the baseline behavior of these assets. And it'll automatically set up alerts for when those baselines are passed. So it learns the behavior of your motors over 24 hours. And so vibration monitoring is a really critical one. Setting up a system that almost acts as like a check engine light is a big application for some of this technology. So I've talked a lot about wired solutions, being able to connect to sensors via wires, via M12 connectivity. What if you have a remote cluster of sensors and you don't want to run a wire to it? This is where something like the R70 serial data radio really comes into play. This R70 serial data radio allows you to send a remote cluster of sensor signals across your factory. So if you look at this animation here, we're gathering vibration data on some critical motors. We're able to capture that data and send that data wirelessly across your factory to the DXMR90. These radios, R70 serial data radios, are extremely plug and play. What you do is you simply twist off the cover, you access the dip switch settings that you see right here, you bind the radios by clicking this button here, and you're done. They're extremely plug and play. And so these are excellent if you don't want to use a cable to run a really long distance. Maybe you have a remote cluster sensors that are difficult to access, and you don't want to run a cable to them. Oftentimes the question is, well, I could spend $100 and deploy an M12 cable in the application. Why would I want these radios? Sometimes the question then goes to be, well, what's the cost of maintaining that cable? To reinstall it continuously over and over? The cost to implement it, the cost to install it? Those questions really come into play. And that's where the R70s are a greatly flexible device for doing that. So if you're looking at replacing wires in some of these applications, the R70 serial data radios are an excellent device for that. So with this portfolio of products that I'm talking about, it gives you the flexibility to do both wired solutions, such as this, being able to capture vibration data, be able to capture different sensors, such as discrete analog, RTD, thermistor sensors, and convert them over to a serial protocol before sending to the DXMR90, or maybe a QM30 vibration sensor, and being able to send that data out via Ethernet IP, Profinet, or Modbus TCP, or sending that data to the cloud. But now what you could do is also deploy both wired and wireless. So you could still have these wired solutions, these wired sensors, wired devices going to the DXMR90. But perhaps you wanted to deploy an R70 to capture data that's maybe a couple hundred feet away from the DXMR90. You have a remote cluster of sensors that you want to send back to your controller. In this case, we're just using a T power supply to power the whole system and a wire consolidation product, a 4-port splitter, to capture that data. So I'm sure many of you are familiar with IO-Link and its rapid growth in recent years. Banner also has IO-Link masters that allow you to send data back via Modbus RTU to the DXMR90 industrial controller. So let's talk about that in a little bit. And what this will allow us to do is allow us to capture data from the many IO-Link sensors that are deployed throughout the world. IO-Link is a consortium. There's well over a couple hundred manufacturers that have IO-Link devices. And with these two IO-Link devices that we see right here, we're able to capture that IO-Link data and send that data out via RS-45 protocol back to the DXMR90 industrial controller. So we're able to capture data from just about any IO-Link sensor. And so this has many different advantages. And people say, well, they see Modbus RTU or RS-45 protocols, well, why not Ethernet? With Modbus RTU, we're able to do things like this. You could have a chain of many IO-Link masters capturing IO-Link data, and you could send it back to the DXMR90 industrial controller that you see right here. And so you could have IO-Link devices. You want to capture all that data and send that data back to your PLC, send it to an HMI or a SCADA, or sending it to your cloud. You can now capture a lot of IO-Link data on a single branch connected to a single port of your DXMR90 industrial controller. And the nice thing is, too, is you could overcome some of the distance limitations of IO-Link. And what are some of those distance limitations? Well, with IO-Link masters, you're limited to 20 meters between your IO-Link device and your IO-Link master. However, with Modbus, you could run up to 1,200 meters of wiring. So it allows you to come up to a solution that's really the best of both worlds. If you're sending data to your PLC, you could have a branch of IO-Link masters that you see right here capturing IO-Link data, and have branches of these devices continuously going on. This is just showing 3, but we could capture more and connect this all to the DXMR90 industrial controller, where you could send that data out to where it needs to go, to your Ethernet PLC, for example, maybe Allen Bradley or Rockwell, to your Siemens PLC via Profinet, or to another area via Modbus TCP. What also this technology allows us to do is it allows us to do things such as wireless IO-Link. So deploying something where you have an IO-Link master and an R70, you have the RS-45 protocol going out, going to the serial data radio. And what we could do here is have some tank level sensors that are T30R IO-Link tank level sensors. And what we could do is we could capture that sensor data, connect it to our IO-Link master, deploy one of our R70 serial data radios, and send the data back to another R70 serial data radio across your factory. And from there, with the DXMR90, you could send that data where it needs to go. And it's really important to mention that this DXMR90, what you do is with the dip switch settings, it could be configured with these dip switch settings to be a client, repeater, or a server. There's just one part number for these R70s. And then when once you bind the radios, you clasp the cover on, you bind the radios, and you're done. So they're extremely easy to implement. So let's talk a little bit about some applications with this technology. So vibration on motors is really an important one. So being able to continuously monitor motor vibration and temperature over time can give you a sense of what's the normal baseline behavior of my motor or my rotating asset. And if the vibration or temperature of that asset was to suddenly go up or go down, we could essentially almost have a check engine light for that application for a vibe tech to go out and check that motor before it leads to a catastrophic downtime event. And so here are some examples of our QM30 VT2s that are mounted on some bearings and on some motors. And these sensors can be connected directly back to the DXMR90. Another thing that's often overlooked is it's important to emphasize that electric motors can comprise up to 60% of the electrical energy consumed in an industrial environment. And in many applications, problems such as misalignment of the motor up to the pump, lack of proper bearing lubrication, overloading, overheating, can really lead to serious damage to a motor. And a failed motor can be a facility manager's nightmare. Production can be stopped, and usually revenues are in jeopardy. And so to prevent this and to really maximize the life of a motor, these simple and cost-effective condition monitoring techniques like I've been talking about can be added. And one of the easiest and most often overlooked methods is to continuously monitor the motor currents and use the results to determine if there's a potential failure before the motor fails entirely. So current transformers provide an extremely cost-effective method to do this that is effective and very, very easy to install and retrofit on existing systems. So check out Banner's, it's called the S15C-CT-MQ, which can be used in combination with the DXMR90 industrial controller to continuously monitor multiple motor currents. And so once you know the normal current draw during operation, by tracking the data over time, you can determine the appropriate current limits and even set up simple text or email alerts in a cloud-based platform, or send this data directly to a PLC, HMI, or SCADA system, for example. So if a conveyor jams, for example, the current at the motor will likely climb instantly. Knowing that this has occurred is extremely powerful, and taking immediate preventative actions can help keep damage and downtime to a minimum. And if you were to look here, just showing how quick and easy these are to install, you simply just clasp these around. And it makes a nice click too, so you know it's installed correctly. And so by using this data, you could kind of really tell a story. So vibration monitoring and current monitoring, you'll start to notice maybe on a conveyor belt, you'll notice as you get one broken tooth versus two broken teeth with vibration data, or three broken teeth. But you could also use it with current monitoring. Tells the story, that data tells the story, and you could use that data to make decisions, set up alerts, improve maintenance schedules, for example, or fix an asset before it fails entirely. And as you can see, you get a new belt and everything is going back to normal. There's one application we worked on recently, and it was in Kentucky, and it was retrofitting injection molding machines. So many of these injection molding machines at this end user, there's over 500 in the fleet, have been installed for decades. And a little bit about injection molding. There's so many injection molded parts. I mean, if you have a coffee cup in your hand from Starbucks, whether you're using on your vehicle, for example, the grill on your truck, all those things are injection molded typically. So they use injection molding to build those products, those plastic products. So with injection molding, you get pellets that are typically fed into a hopper. And the pellets go through a drying process to make sure there's not humidity and moisture in those pellets. And what happens is they go through this feeding process where it's driven by a piston in a hydraulic cylinder, and it moves these pellets through what these are called heater bands that you see right here. And what these heater bands does is they melt up these pellets continuously. And by the end of this line, it's a molten plastic before it goes into the mold itself, and then the injection molded parts get clasped together and you have a molded piece. So this particular end user, they were starting to see some failure events on these assets. And they essentially wanted to have a check engine light that they could see from wherever they were in the world on their iPad. What's going on with my machine? What are some of these pain points that we're seeing, and how can we continuously monitor them? And some of these pain points revolved around vibration on the motor. So being able to continuously monitor the vibration in motor in their injection molding machines. Being able to monitor to see if there's oil leaks on their piston. What they were finding was on the piston, there'd sometimes be oil leaks on their injection molding machine. So oil would leak past the piston. And if that was to happen, they would have to order a new cylinder, and that could be up to a 2-week lead time. And that 2-week lead time would be 2 weeks of downtime, essentially. So what they wanted to do is monitor and see if there's oil leaking past that cylinder. So we actually deployed temperature sensors in 2 locations. And if oil was to leak past that cylinder, there'd be a 100-degree spike in temperature. They also wanted to monitor temperature and humidity in the hopper. So as the weather fluctuates, there's more humidity, there's more moisture in the air. And they wanted to know when that moisture. They also wanted to monitor the current on these heater bands. So using current transformers, they could monitor the current on these heater bands. And if they were to notice that one heater band was to fail, they would have consistency issues with their molds. And in this particular customer, one of their issues was called splay. So they get a surface defect on their injection molded parts. And so they wanted to know when any of these heater bands was to fail. And then lastly, they wanted to monitor the current on their motor as well. So both vibration, temperature, and current on their motor. So we essentially were able to plan out a system for this to monitor this type of process with Snap Signal technology. So monitoring the motors, monitoring the temperature and humidity in the hopper, and actually using thermistors, which we could convert to that unified serial protocol on that hydraulic cylinder. And we're all able to connect this back to the DXMR90 with the actually deployed inside their cabinet. And then in addition to that, we had some current transformers monitoring the motor. So we're able to plan out a system before even going into the end user. And installation took about an hour to install this overlay architecture onto their injection molding machines. So we deployed the current transformers, monitoring the heater bands, but also the vibration, or monitoring the motors as well. So 2 areas. A temp and humidity sensor, which is this product right here, in the hopper. So continuously monitoring the temp and humidity inside that hopper to notify them if maybe there's close to having injection molding pellets clogging up their process. They wanted to know that before it actually happened, or actually using that data to maybe change up some of their injection molding pellets over time. That's something they're looking at. And then from there, we're able to create a very simple dashboard. In this case, we're using Banner Cloud Data Services to set up a very simple dashboard for monitoring some of these critical assets in their machine. And the nice thing is about this overlay technology is we're not diving into the control cabinet, we're not touching the PLC code, and it really doesn't matter what control system the end user is using in this case, they may have injection molding machines that are using all these different control systems, and they just want to have one solution in place for gathering all this data. And this particular end user, they're building grills, they're injection molding grills for a lot of the automotive companies in the United States. So think of the grill that goes in front of your truck, that chrome-plated grill, that's what they're building. And they essentially wanted to have a check engine light for all their different injection molding machines throughout their process and throughout their facility, and to monitor those assets continuously. So I want to quickly talk about, I could spend a lot of time talking about applications and where we've deployed this. I also want to emphasize that we have a new product at Banner. If you're in the IO-Link world, we have a new IO-Link Master that just got released. And if you look at it, it looks very similar to the DXMR90 I was talking about before. However, instead of the 4 Modbus ports, these are IO-Link ports. And it's an Ethernet IO-Link Master that has Ethernet IP and Modbus TCP. And so if you're looking for an IO-Link Master and you're struggling to find one, something that's readily available, reach out to us at Banner. We've got a lot of different IO-Link products that you could look at. So just to highlight it again, IO-Link, we could spend a lot of time talking about IO-Link and being able to use it with IoT technology. But this is the new DXMR90 4K IO-Link Master. It's exactly the same form factor as our other DXMR90 I was talking about, but it has the 4 IO-Link ports. And this essentially allows you to send IO-Link data to your PLC, HMI, or some of the cloud systems. IO-Link is extremely powerful in some of these systems where you're deploying IoT as well. And another thing is, one of the benefits of IO-Link is what's called data storage mode, or backup and restore mode. So you could actually store the configuration of your IO-Link device directly on the IO-Link master port. And so what do I mean by that? Well, many devices nowadays, they have programmable buttons on the device itself. So you can have many different configurations of the device, virtually infinite configurations of some devices, where you could set the range, the analog start point, the analog end point, the output behavior of the device. But what if you're in the field and lo and behold, a forklift driver was to run over that device? With IO-Link data storage mode, you could simply plug in a new one, set it and forget it, and it makes device replacement completely hands-off. It stores the device configuration directly in the port of the IO-Link master. So we have 3 different versions of the IO-Link master. We have the ones I was talking about before that have the RS-45 or Modbus RTU outputs on these male M12 ports right here. We also have this new product right here, which is Ethernet directly out. So I want to leave plenty of time for questions, Q&A. Thank you so much, everyone. I know it's a lot of information to cover. Thank you very much for joining. I really, really appreciate it. Is there any questions coming in?
Sean, thank you so much. Great presentation there on this new technology from Banner. There were a couple questions that came in, and those that are still with us, if you have other questions, please look at the chat or pop them in the chat at the bottom right. And I sent one about the availability of what frequency did the R70s work on? And it was a 900 or 2.4.
We have versions of both. So we have a 900 megahertz and also 2.4 gigahertz. So we have versions that are available for both of those frequencies.
Both serial data radios. Another question.
So another resource that goes over this, we have a Snap Signal brochure, and it goes over all these products in a little bit more detail. So if you want some more information on the products and the R70s as well, this is a great document. I use this almost every day for speccing out IO-Link systems and speccing out Snap Signal systems. And it's called the Snap Signal brochure. It's about 32 pages long, a lot of great content, images in here, part number keys, everything from what connectivity you need to select for building a system, and even things on like the R70 serial data radios I was talking about before, some information on those in a little bit more detail. Part numbers, just showing the part number for the R70 with the 200 gigahertz is the R70 R2 R70 SR2MQ is the part number for that one. And the one for the 900 megahertz is the R70 SR9MQ. So there's just a small difference in the part number, 2 versus 9 for those two different frequencies. Great question.
Looks like a great brochure. Now, for those that attended and signed up, I'll get an electronic copy and we can send that out to everyone. So great information. Had another question that came in is, what is the availability of IO-Link Masters on Profinet?
So right now we're working on having Profinet available on our DXMR94K. Currently it's Ethernet IP and Modbus TCP, but in the next couple of months we'll have Profinet available on our IO-Link Master as well. And it'll simply be it'll be coming shortly. So be on the lookout for that. We'll be sure to announce that when that's available. And I'm really excited about having that available on our IO-Link Master.
Cool. They did ask for what's the availability.
Availability.
Well, that's another question.
We have a lot of them that have been ordered. So, stock right now is low. However, our lead times are significantly better than I know a lot of our competition for IO-Link Masters. Significantly shorter. We're able to build them. So, yeah, I'd say keep ordering them. We're really cranking them out. So, currently we're low on stock, but there's been a huge demand for the IO-Link Masters. But we're able to build them, so it's been exciting.
Cool. Another question from Phil came in. Are competitors offering anything like this?
I haven't. Nothing is comprehensive to this. Some of our competitors may have converters, but nowhere near close to what we're doing, and they're not following this methodology. What I talked about in this presentation for capturing that data, really from just about any source. We have a really far more robust portfolio, and they're not following this methodology. So really, there's no real direct competition for the overall Snap Signal solutions that we're providing.
Great. Got another question that came in on the Banner Cloud services. Is that a monthly or yearly service, paid subscription type of thing?
Yeah, so it'll depend on how many data points you're monitoring, how many registers you're monitoring, and it'll be a yearly. If you go on the bannercds.com, you'll be able to see the different pricing structures. We recently launched Banner CDS, a new version, and it's a beautiful new interface. So I really highly encourage you to go on to bannercds.com, or if you actually go to Banner's website and look at Banner's cloud data services page, it'll walk you through all the different pricing, and it really depends on how much registered data you're gathering from the devices.
Thanks. Another question from Michael. Can you explain more about using DXM unit to connect to cloud services via cellular?
Yeah, so this device, it doesn't have cellular, the DXMR90 itself doesn't have cellular connectivity. However, Banner does have other DXM products that allow you to push data cellularly to the cloud. So maybe if you wanted to not use the DXMR90, you wanted to use a DXM1200, which is a cellular enabled DXM, you could certainly use that as well, but that DXM doesn't have the 4 Modbus ports at the bottom. It just has 1 typically. And then also, I really want to mention this as well. This port here on the DXMR90, it's configurable. So it could allow it to serve as a 5th Modbus master port. So I just wanted to emphasize as well. I think I forgot to mention that. So another additional port for the DXMR90X1. Which is this product right here. But there are other DXMs that Banner offers that allow you to push data to the cloud via cellular connection. So great question.
Awesome. I think that's all I see for questions. If there's anybody else that would like to drop a question in the chat. I think that's what I see for now. Any closing comment, Sean, other than?
I'd say I encourage everyone to go to Banner's website and check out this technology. And if you have any questions, feel free to reach out anytime. Banner's put a lot of this content in a location called snapsignal.bannerengineering.com. It'll give you a great overview of the products, and you'll also be able to find the brochure on that page as well. So be sure to check it out, and also reach out to us if you have an application. You're interested in deploying some of this technology, some of this condition monitoring and IoT technology, or if you're also interested in maybe deploying one of our IO-Link Masters for IO-Link systems. I highly encourage you to reach out to us. We've got a great team of technical experts that'll help you every step along the way as you're deploying this technology. We've got a sales enablement team here at Banner that has a really, really high level of technical knowledge and expertise in this technology that'll help support you. So, got your back. If you have any questions, just feel free to reach out to us anytime.
Sean, thanks. And on behalf of GCG Automation, Empire, C&E Advanced Technology, AC&D AdCon, we're all channel partners with Banner Engineering. We're here to help you, our customers, to share more on the Snap Signal technology from Banner.
Well, thank you very much, everyone. I really, really appreciate the time, and have a great rest of your day.